Okay, this is for Astronomy 400. This is lab number 3, the orbits of the planets. And basically starts off talking about Kepler's third law, which states that the square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of the orbit. It means that the time it takes the planet to orbit, the square of the time it takes the planet to orbit the sun is proportional to the distance the planet is from the sun cubed. Okay, so we'll take A as the distance from the sun to the planet. We cube that. We divide that by the period squared. That's going to be equal to a constant. Okay, so this ratio stays the same. Whatever the cube of the distance the planet is from the sun divided by the period that it takes the planet to orbit the sun squared, those two numbers are always going to give you the same number. Now, if we only deal in units of astronomical units, in other words, the average distance between the sun and the Earth for A, and then T, the period, we do that in Earth years, then A cubed over T squared equals 1. Okay, well, it equals 1 for Earth because this is 1 for Earth, this is 1 for Earth. 1 cubed is 1, 1 squared is 1, so we'll get 1. So that must be true for all the planets. Okay, so A cubed equals T squared. So here are the orbital semi-major axes for the different planets. So Jupiter 0.39, and then Earth years, it takes 0.24 years for Mercury to orbit the sun. So we simply do this. A cubed, that's the 0.39, we cube it. We get 0.059 astronomical units cubed. Then we take the 0.24, that's the period, we square that. 24 Earth years squared equals 0.058 Earth years squared. You can see that the 0.059 and the 0.058 are very, very close. We're not going to be perfect because these numbers are really rounded off to 2 digits. These have 3 digits of accuracy, but most of these only have 2. Here we got 2, 2, 2, 3, 2, 2, 3. So these numbers, we know these numbers further out. If we had them further out, these would probably be good. We can see these are much closer numbers, but we're not going to worry about that. So now I put in for Mercury. I showed you how to do Mercury. What you want to do is prove to yourself that's true for the other 7 planets in the solar system. Earth's just going to be 1 and 1 here. So, you already know what that's going to be. Earth orbital, one astronomical unit is defined as basically the distance the Earth is from the sun, and then 1 Earth year is how long it takes the Earth to orbit the sun. Okay, so you can do the rest. These are going to get to be pretty big numbers. Okay, if you take a look up here, like 30.1, you're going to have 30.1 cubed and 164 squared. Okay, so keep in mind that these are going to be some big numbers when you get down here. Okay, during the time a planet orbits the sun, it reaches a point called Aphelion. That is furthest from the sun, which means the planet is farthest from the sun. After traveling another 180 degrees, so it's over here and it completes half its orbit, it now is at a point called Perihelion. That is when the planet is closest to the sun. Okay, so you've got in its orbit, because they're not perfectly circular. Kepler's first law. Kepler's first law: the orbit of the planet is an ellipse with the sun at one foci. That means that the orbit is not perfectly circular as the Greeks believed, but an ellipse, where the planet's distance from the sun varies over the course of its orbit. Okay, now it's pretty consistent. Whatever the aphelion is one time around, it's going to be pretty close to the same aphelion the second time around, and so on. Okay, same for the perihelion. So the orbit of the planet. So we open Stellarium and center on Mercury. So here I got Stellarium right here. I'm going to go over here, find the location thing, and type in Mercury. And so now we are looking at Mercury. Okay, we can go back and see where the Mercury is relative to the sun. We can go into Mercury. Okay. So right now, what we want to concentrate on is distance from sun. Okay. Right now, Mercury is 0.336 astronomical units. If you like to have kilometers, that's how many kilometers it is, million kilometers it is. It's 50.279 million kilometers from the sun, but we'll concentrate on the astronomical unit part of it, 0.336. Okay. So then we go back over here, and so distance from the sun. This is the number. This is where it is. There you got the whole list. There's Mercury. You got all this other stuff going on here. It's down here. You don't want to look at just distance. That's distance from the Earth. You want to look at distance from the sun. You want to watch this number right here. Okay. Make sure Stellarium is set to today's date. This is how you click this guy to set it to today's date. So I come over here to Stellarium. There he is right there. I click it to today's date. So 20/26/17. So June 17th, 2020. 6/17/2020. Okay. So we're also at 4:31. So this is going to be in that 24-hour clock. 16:31. So 4:31. It's the same thing. Okay, so we're right now at this point in time. Okay, you may need to experiment around to get comfortable, because what we're going to do is we're going to go forward in time. We're going to watch that distance from the sun. Okay, if it starts to go up, then we're looking for aphelion. Okay, the very first aphelion. If it starts to go down, then we're looking for the first perihelion. So let's go. So anyway, here's how you do all this stuff. Okay, once you find aphelion, you can read through this. I'm going to talk you through it while I'm doing it here. Okay, so there's Mercury. I already filled in some of these numbers for you so you can check as you go along and try to fill in the rest. All right, so we're going to run into the first aphelion pretty soon. 6:22. It's 6:17 now. So we're reaching the point where the sun is going to be, or Mercury, I'm sorry, is going to be furthest from the sun really quickly. Okay. So let's go over here. Now, these are how I control. So this is what sets it on today's date. Then this is how I speed things up. Watch what happened with the time up here. I speed it up even more. And then if I speed it up enough, I can see the days actually start to change. Speed it up even more. So there we just went 19, we went 20, 21, 22, 23. Keep going. We'll see this go to 07 for going to July. Going faster, we'll see this go 2021. Okay, now, and you can go really, really fast and get carried away and hit this too many times, and then boom, look at that, we're in 2056. So then you hit this, and that puts it back to actual time. Okay, then I hit this again, and boom, we're right back to right now. Okay, so this does the fast forward, this does the reverse. Okay, so we want to find out when this number here it is right here, distance from the sun. We're at 0.463. So I come here and I hit this once, I hit it twice, I hit it 3 times. 0.463, 0.463, 0.463. That's pretty slow. See, we're only going like here's 18. We're still today, right? So we may have to go faster. Okay, so now we're going a little faster. What is this thing up here doing? Distance from the sun, 0.464. Okay, we went up a little bit, but we're going up very, very slow. But there we went to 0.465. So we're heading towards the point where Mercury is going to be furthest from the sun. We're looking for aphelion. But I'm getting bored, so I'm going to go faster. Okay, so then watch this date here, 21, 22. So we're at distance from sun, 0.465. Oh, now it's going back down. So let's go this guy. So we went past it. Okay, so we're at 0.460. So I'll hit the reverse. Let's go backwards in time. See, we're at 2026/29. So let's go backwards in time. So boom, boom. And I'm going to get it to where I see this number change at a rate that I can handle. There's 28, there's 27, I can handle that. This is from sun, 0.466, 0.467. Okay, right in there. It went from 466 to 467. I come back over here. Now when you're doing this, you're not going to be trying to talk at the same time. Okay, I'm going, okay, we want to go forward now. Yeah, okay. So let me go forward a little bit. Now I can see these numbers are changing. Maybe we get these changing a little faster. 12, 13. Okay, maybe I'm okay there. So 0.466. I want it to go to 0.467. There it is. So let me hit this. So we're on 0.467. So the date is 2026/21. Okay, now if you look at the table I made, it's always also going to be true for the 22nd. Okay, 6/21 is 6/22. It's someplace in that range. We're not going to be able to be very precise. If you take a look at the kilometers out here, this changes a lot more. This is a more accurate distance thing, but let's not worry about that. That just makes it more confusing. Let's just concentrate on that. You can see that if I go forward. Okay, so now I'm up to 622, and we're still at 0.467. So it's in this range here. Just put down a number you see here when you see it at the highest number here. Okay, so right now we're 622, and that's what I had over here is 622. Okay, so then I put down what it is, 0.467. So that is aphelion. That's when Mercury is closest to the sun. Okay, now we want to find the first perihelion. Okay, so what I'm going to do now is come over here, and I'm going to go again. I'm going to watch the distance from the sun, and I'm going to watch this number go down now. Oops, I don't want to do that. I want to hit this. Okay, so it's not going down very fast. Now it's going down pretty rapidly, and it's going back up. So I missed it. So let me go back this way. 0.63, 62, 58, 57, 56, 55, 53, 51, 49, 47, 42, and it's down into 422, up to 419, 17, 12, 409, 399, 380 something, 370 something, 360 something, 350 something, 340 something. Probably wish I went faster. Okay, it's slowing down, it looks like 308, 308. I think it went to, okay, right in here someplace. It went to 308, then it went to 307 for a second there, it looked like. I'm not going to worry too much about trying to get it precise. Okay, so let me go. I may be going the wrong way. I'm not sure. We'll see in a second. Yep, I am. All right, so it's 308, 307 was where it was. And I went past it. You got to mess around with it, and you get the hang of it. So now we're going down. We're going down slowly. So there we are at 308. Oh, right there, I think for a second I went to 307, but I'm not going to worry about that. Okay, here's the date. 2805. 2805. 85. Okay, so yeah, we got the same date there. Okay, so now we've gone from Mercury being the furthest from the sun at June 22nd to August 5th. It's closest to the sun. Now let's go back. Now you see there's about a little less than 2 months here. This number here is going to be a little bit less than 2 months forward. Okay, we can predict that because it's very, very symmetrical. All right, so we went Stellarium. Let me go forward. So we're watching distance from the sun. It is now going up, and you can see it's going up to 464. It went back down. I passed it pretty quickly, didn't I? So I'm looking at this number here. So watch, it's going to start going. I'm going backwards in time because we overshot it. I overshot it. So let me go backwards in time. Let me get that number moving. That 0.41 is going up. It's going up. Yeah, we want it to go up. We're looking for aphelion again. 17, 18. Here's another thing too. Okay. It's going to be the same, basically the same number. See, Mercury's first aphelion was 0.467. So it's going to be 0.467 again. They're going to be close. When you get out here, these guys weren't exactly close. You see, when I did Saturn, it was 2033. That's the date. Yeah. Oh, it was 9.015. Compared to 9.031. Okay, so but up here they were exact. So let's look for a 0.467. So let me go 0. So I'm going forward. I'm going. What are we doing? Distance from sun. No, we're going down. Okay, let me go back the other way. 0.467 is going up. 0.44344, 0.53, 0.4623456 there. Okay, it's in here. Okay, so the date is 9/18, which hopefully is close to what I have over here, and I have a date of 9/17. Okay, so 9/18, 9/17. I'm in the neighborhood. Now we've already got the sun, the Mercury going around the sun once, so that was a complete orbit. So what is that? We got 9/17, 6/22. That's approximately. It's a little under 3 months. Okay, 6, 7, 8, 9. Let's call it 3 months. Okay, we're gonna do a lot of estimating here. We'll call it 3 months. 3 months is a quarter of a year. Okay, so if it's a quarter of a year, it's 0.25 of a year. So it takes Mercury 0.25 years to orbit the Earth. Okay, so and we look at what we had on our table way up here. 0.24. So 0.24 to 0.25. That's pretty good. I would say very good. All right, let's go down to. I don't want to take too much time. Let's go down to Neptune, the other extreme. Okay. Now, I did the Earth for you, and I did Saturn for you. Then you want to do the other ones here. And if you want to have a solution guide, I'll tell you what. I'll put this on the screen for 5 seconds. This is everything. This is all of them. Okay. So now what you want to do is go back, and then if you want to look at that, just go back to this point on YouTube, hit the pause button, and then you can see what the solutions are. All right, so let's go do the other extreme. We'll do Mercury. So the first thing I want to do, I go Stellarium. I'll put it back to current time. That's this guy right here. Remember, if we take a look here, I got him up here for you. That sets it to right now. That sets normal time rate. So if you're going fast forward really fast or reverse very fast, you set normal time rate and then to current time, and that's where you want to start all of these. Okay, so we'll do Neptune. Oh no, I did Neptune for you. Okay, so let's do Neptune. So we come over here. Well, first of all, we come here. We'll do that, and we're back to right now. Okay, this is right now. This is this moment right here. We go over here and we want to find Neptune, and it goes and finds Neptune for us. Okay, we'll go in pretty close. Okay, so now, as we speak, that'll get off of there. The distance to Sun, right there, distance from Sun, 29.9, about 30 AUs, 30 times the distance of the Sun to the Earth. So it's out there 30 times further from the Sun than the Earth is. Okay, so let's see if these numbers are going to start going down or start going up. So I come down here. Now, the total orbital period for Neptune is going to be 164 years. So the first thing you want to do is see this change at a rate that you're comfortable with, okay? So what I'll first of all do, I'm going to figure out if it's going to go up or down. So distance from the Sun, and see, we're still on 2020. It's going down, it looks like. So we're heading towards Perihelion. So now we can go a little bit faster. So we're still on 2020. See, now watch, this number changes. Now I can make it change a little bit faster than that. Okay, that's pretty good. Okay, so let me put this over to return to constant rate. So we're down to 28 point. Are we going back up again? We're going back up. Okay, so we missed it. I missed it. Oh, we're at 2055. No wonder. See, you can watch. I'm trying to watch and show you stuff and talk at the same time, so it's a little more complicated. So now I want to go backwards in time because I overshot it. So let me try to get this number so it's changing at a rate that I'm not going to be here all night looking at this. Man, it's still not changing much. Okay, let's go a little faster. 54. Okay, so that's pretty good. All right, distance from Sun, it is going down. We're at 52, 2052. 17, 16, we're at 51. This is going to take a little while, but I'm going to be patient. 49. I think I can go a little bit faster than this. Okay, so 8. Oh, went back up. Darn it! It's a good idea to keep this there. Okay, so 29. So I went past it. so I in reverse went past it. Ah, get out of here. Okay, so let's go back. Expecting to go down. I'm going down. 44, 43, 42, 41, 40, 39, 838, 837. Again, I'm looking here. I lost it. 24, 823, 822, 821, 20, 19, 18, 17, 16, 15, 14. See, this is what I said. I want to go a little bit faster, and then I ended up overshooting it. 7, 6, 7. Okay, there it was. So it's someplace in here. I'm not going to try looking for it. It's in this range. It's this year right here, 2043. So 2043. Okay. And then now we go looking for Aphelion, or I'm sorry. So now we don't need we the first thing we got was Perihelion. So we don't get the we put X's in there. We don't fill that in. Just like we did when we first got Aphelion, we didn't do the second Perihelion. We are going to get 2 Perihelions here, so we don't need the first Aphelion. So let's get Aphelion, and then what we'll do is, again, same thing. You look here, it's 2043, the year 2043. That is when Neptune will be next at Perihelion. Now let's start looking for Aphelion. So I'm going to watch this 2043, see it change at a rate that's not too slow. And 2043, still slow. 24. Okay, I guess we can do that. Okay, so there's distance from Sun. The number is going up towards Aphelion. And we're going year at a time. This is going to take 80 years. Let me go a little faster. Okay, so there we're watching. Oh, it's going back down. I overshot it. Okay. Going back down. What did I do? I'm going the wrong way. Okay, I don't want to spend. Okay, this will take forever. I'll upload on YouTube if I don't. Okay, we're going back up. 17, 18, 20. 9. So we're at 31, 1, 3, 4, 120, 192. So you just have to watch the last numbers. And we're still going up. Oh, there, we did it. Okay, it started to go back down right then. So we're in the neighborhood. 20. Oh, look where I am, though. I went way past it. Okay, here, let's do this. Let's go back to now. Okay, regular rate. Let's look at what I had from before, just so I'm not wasting time here. All right, so 2043, and then what we're looking for is 30. So 2125 is what we're looking for. Wait, that is 2125. Anyway, I'm going to look for 2125. That's not right. Yeah. It should be 80 years. 20. Oh yeah, 21. Oh yeah, 21. Okay, 2040. That's 80 years. Okay. Okay, I'm going to cut it short here. I hope you get the idea. So this one you kind of go slow. When you practice at it, you'll get better and better, and then you'll be able to do it and fill it in and all that kind of stuff. It just takes a little bit of practice. And again, I'll put it up there for a second. If you want to have the solutions, just go to this part on YouTube and hit the pause button, and there they are. Okay, there are the solutions. All right, so this is lab number 3. I'm going to upload this all tonight. It's June 17th. Worked on this yesterday and today. It took me quite a while, but I got it done. So I'll say, for now, since it's night where I am, or afternoon, I'll say good afternoon, leading into a good night.